come to film.
Yep, gonna need a much bigger lens.
Welcome. This video introduces Rolly, an autonomous robot dolly and communication center ecosystem engineered specifically for high-end cinema workflows using the Sony Venice 2. This project was developed by Don Lucky Jr. for Amblin, Universal, and Sony. Rolly features hardware designed for seamless camera integration. This includes a custom low-profile mount for Sony Venice 2 configurations, a precision-machined 16-wheel bearing truck for vibration-free movement, and an engineered low center of gravity for stability during rapid acceleration. The system architecture is built for reliability. It includes a unified power hub with redundant battery arrays, a centralized nervous system that acts as a robust communication hub for your equipment, and a rugged build designed to endure the demands of professional film sets. Rolly utilizes LiDAR shadow tracking for precision. This includes continuous spatial scanning, automatic operator motion mirroring to track camera movements, and vector match moving, which combines physical tracking with camera telemetry to ensure seamless framing and eliminate jitter. Communication is key to this ecosystem. Rolly offers a proprietary talk channel for low-latency synchronization with Blackmagic systems, multicam telemetry for frame-accurate timecode and genlock, and real-time syncing to eliminate drift across complex multi-camera setups. Finally, the Rolly system integrates directly into your post-production workflow. By stamping movement and spatial data into metadata, it allows for instant ingestion into DaVinci Resolve and Fusion, enabling 3D match move tracking for immediate VFX work. This matrix highlights how the Rolly robotic ecosystem improves upon traditional grip rigs across key areas like operator tracking, system communication, and post-production pipeline integration. Thank you for joining us to explore the Rolly ecosystem and its potential for your next production. Please see these references for the image sources used in this video. Welcome to the official production deck for Blues Brothers 3000, brought to you by Mesomecha and Amblin Entertainment. This video outlines our vision, strategy, and the technical standards guiding this ambitious project. Our production is a high-fidelity homecoming, carefully crafted under the mentorship of Amblin Entertainment. We are committed to maintaining the technical rigor championed by filmmakers like Spielberg and Nolan, blending legacy storytelling with cutting-edge production technology. The Kinoscope standard defines our workflow. We use proprietary HDR LUTs to bring neon depth to classic blues tones, an agile direct-to-studio production process, and AI-driven storyboarding to ensure absolute precision in every shot. Our 1R philosophy centers on the one-take performance capture. By prioritizing raw, uninterrupted energy, we maintain true performance integrity, complex choreographic continuity, and utilize minimalist editing to maximize audience immersion. At the heart of our technical setup is the Falcon rig. This includes an iPhone 17e for agile, high-speed capture during chase sequences, paired with an iPad Air 2 monitor, acting as our centralized AI hub for real-time monitoring and technical tracking. Production leadership is anchored by industry veterans. John Landis returns to guide the franchise back to its cinematic roots, while Dan Aykroyd and Jim Belushi serve as executive producers, safeguarding the spiritual and musical legacy of the project. The film follows a distinct geographic narrative arc. The journey begins with a recovery mission in Lake Michigan, moving through the Chicago River, assembling at Navy Pier, and culminating in a final touchdown at the historic Joliet site. The story originates in the depths of Lake Michigan, with the salvage of the SS Leluc LaBelle. This critical sequence unearths a 1941-era tank, creating a mystery that effectively bridges the past with our futuristic 3000 timeline. The Chicago River serves as our silent corridor, facilitating the mothership's transit through the heart of the city. We are coordinating with CDOT to capture high-impact visuals of the vessel passing beneath the city's iconic steel bridges. At Navy Pier, the Ferris wheels serve as the physical propulsion core for our intergalactic assembly. This sequence represents the definitive culmination of Chicago's rich mechanical history and our narrative's extraterrestrial technology. The final stage of our journey brings the mothership to a reproduction of the Pilgrim Baptist Church at the Joliet Museum. This homecoming signifies a return to the Brothers' spiritual center, completing our geographic arc. We are anchoring our musical soul with Buddy Guy. We've planned a pre-show recording session at Legends, connecting directly to the venue's soundboard to ensure we capture the raw, pristine essence of a true blues legend. The project's prestige finale is set for Radio City Music Hall. We have initiated formal inquiries to secure this iconic venue, which will serve as the ultimate backdrop for the film's final musical masterpiece. Production logistics are well underway. We have prepared requests for all major locations, including waterways and municipal landmarks, and are actively managing permits and memorandums of understanding to ensure a seamless filming schedule. By integrating the 1941 salvage into our current narrative, we provide the historical gravity required for this prestige production. This narrative through line ensures Blues Brothers 3000 is far more than a sequel. It is a monumental expansion of the cinematic universe. This concludes our presentation for Blues Brothers 3000. Thank you for your time, and we look forward to moving ahead with this exciting production. Let's ride. For transparency, this video utilizes various licensed and public domain imagery. We have documented all relevant image sources for your reference here. This final slide continues the documentation of our image sources, ensuring full credit is provided for the visual assets used throughout this production portfolio.
Welcome to today's custom-tailored exploration into the source material. I'm really glad you're joining us for this one.
Yeah, we have some incredible tech to dive into today.
We really do. So the topic today is based on a presentation by Don Lockey Jr.
Right, for the Amblin, Universal, and Sony Production Initiative.
Exactly. And we are looking at something called Oroli, which is, it's an autonomous robot dolly and communication center ecosystem.
Which is quite a mouthful, but, it's engineered exclusively for these really high-end cinema workflows.
Right, and that's the hook here. I mean, this isn't just a basic piece of film equipment.
Yeah, not at all.
It's essentially a robotic ecosystem that shadows human camera operators. It acts as a centralized nervous system for the whole film set.
Yeah, which is a massive deal when you think about the usual chaos of a physical movie set.
Oh, absolutely. So our mission today is to extract the smartest insights from this slide deck so you can actually understand how the bleeding edge of cinema robotics works.
And it really starts with the physical foundation. I mean, Rolly is built specifically to handle the Sony Venice 2.
Right, which is not a small camera.
No, it's huge, especially when you're talking about accommodating its 8K or 6K full-frame sensor blocks.
And the Rialto extension modules, too, right?
Exactly. So to carry all of that, Rolly sits on this precision-machined 16-wheel-bearing truck.
Wow. 16 wheels.
Yeah, and it rolls across standard aluminum speed rails with absolutely zero vibration.
Okay, let's unpack this. Because, when I think of an extremely low center of gravity and a 16-wheel design, I'm thinking of, like, a high-performance sports car.
That's actually a great way to look at it.
Right, like one engineered to handle rapid acceleration and deceleration without spilling a single drop of coffee, or I guess in this case, without jittering a multi-million-dollar shot.
Yeah, that analogy is spot on, because Rolly is built for these rigorous feature film environments.
Where you can't afford any mistakes.
Right. Physical stability is the vital foundation. I mean, you cannot fix bad physical movement with software later on. It just never looks right.
Yeah, the jitter is baked in.
Exactly. And that dolly base also doubles as that centralized nervous system we mentioned.
Oh, right, the unified power hub.
Yes. It houses redundant V-mount and gold mount battery arrays, so it's sending auxiliary power and acting as a hub for wireless transceivers, all in a single enclosure.
Wait, so it's powering the heavy camera and the robot's drive motors at the exact same time?
At the exact same time, yeah. It maintains absolute mechanical reliability without dropping voltage.
That's incredible. But, a perfectly stable, incredibly powerful chassis is ultimately just it's like a high-tech remote control car, unless it actually has the intelligence to know where to move.
Right, it needs to know how to move on its own.
And that leads directly to how Rolly actually sees the set.
Yeah, its spatial awareness is really next level.
Because it's using LiDAR, right?
Exactly. It has this dedicated high refresh rate LiDAR array mounted right to the chassis.
So it's just constantly firing out lasers to map the space.
Constantly. It broadcasts these spatial mapping signals to track everything, and that enables a feature called operator motion mirroring.
Here's where it gets really interesting. Because if it's mirroring a human operator who is off the track,
Right, walking around freely.
yeah, is it essentially acting like a digital dance partner?
Yeah.
I mean, how does it keep the footage smooth if it's following the unpredictable, shaky movements of a human being?
What's fascinating here is how it uses something called vector match moving.
Vector match moving.
Yeah, so Rolly doesn't just blindly follow the human's every little step or twitch.
Okay, that makes sense.
Yeah.
Because humans stumble and sway.
Exactly. Instead, it combines the physical off-track spatial tracking from the LiDAR with the camera's internal telemetry.
Like where the lens is actually pointing.
Right. It takes all that data and completely eliminates the high-frequency jitter. It ensures seamless framing even while it's mimicking the broader path of the human.
Wow. So it's basically extracting the creative intent, but stripping away the human flaw.
That is exactly what it's doing.
Okay, so we've got the physical movement smoothed out. But the deck also talks about cross-ecosystem communication.
Yeah, the proprietary talk channel.
Right. But I have a pushback question here. If Rolly is engineered exclusively for the Sony Venice 2, why does the presentation specifically highlight syncing with Blackmagic camera units?
It does seem counterintuitive at first.
Yeah, I mean, why mix the ecosystems at all?
Well, if we connect this to the bigger picture of how complex multi-camera feature productions actually work, mixed camera setups are just inevitable.
Really? Even on massive budgets?
Oh, especially on massive budgets. You might have the Venice 2 as your main A camera, but your B-roll or crash cameras might be Blackmagic.
Oh, I see.
And the problem is, getting absolute frame accuracy across these mixed ecosystems is historically very difficult.
Because of sync drift, right?
Exactly. Sync drift is a massive, time-consuming headache for editors.
Because the different cameras have different internal clocks, and they literally drift out of alignment over a long take.
Yes. But Rolly features multicam telemetry. It transports high-bandwidth timecode, genlock, and telemetry data across all primary and secondary units.
Wow, so it acts like a digital metronome for every brand on set.
Right. It completely eliminates that sync drift, which is an absolute lifesaver on set.
So what does this all mean for post-production? Because it seems like it's grabbing a ton of data.
This is where it gets really brilliant. It takes all of this synchronized data, the physical movement, the LiDAR maps, the time code, and hands it directly over to the post-production team.
Ah, the metadata-driven pipeline.
Exactly. Every single movement of the robotic dolly, the tracking rail encoder, and the LiDAR spatial log is stamped directly into the clip metadata.
So it's like baking a cake where the ingredients just automatically mix themselves inside the oven.
I love that analogy.
I mean, normally a VFX artist would spend days manually tracking a camera's movement frame by frame, right? Just add CGI later.
Yeah, it's incredibly tedious work.
But here, Rolly just hands them the finished math instantly.
Yes, through Fusion Spatial Import. These captured depth maps and trajectory data are ingested directly into node-based DaVinci Resolve or Fusion environments.
So it just instantly generates a 3D match move camera track. That's wild.
This raises an important question, though, about the value of knowledge and data application.
How so?
Well, data is only useful if it's accessible. By stamping every movement directly into the metadata, Rolly removes the barrier between physical production and digital post-production.
It totally streamlines the entire visual effects pipeline.
Exactly. You just drop the file in and the tracking data is already there.
Well, this has been quite the journey today. I mean, looking at the whole Rolly ecosystem.
It really is a game changer.
We went from a rugged 16-wheel Sony Venice 2 powerhouse to a LiDAR-equipped shadow tracker.
To a cross-communicating multicam hub.
Right. That instantly feeds DaVinci Resolve with 3D match move data. As Don Lucky Jr. said at the end of his presentation, let's ride. And for everyone listening, I think it's important to understand why this matters, even if you aren't shooting a Hollywood blockbuster anytime soon.
Yeah, why should the everyday listener care?
Because understanding Rolly shows how the future of technology is really about breaking down silos.
Oh, for sure.
It's just a masterclass in how hardware, spatial awareness, and data management can converge to entirely remove friction from the creative process.
It's beautifully designed, and it leaves me with one final, maybe a bit provocative thought for you all to mull over.
Well, let's hear it.
If every microscopic movement of a camera, its tracking rail, and the human operator is perfectly mapped by LiDAR.
Right.
And stamped as metadata to be instantly recreated in a 3D environment. At what point does the physical movie set stop being a real physical location and simply become a real-time motion capture stage for the digital world?
Hey, Rolly, follow me.
Wait, look here. I need you to go quicker. Hey, Rolly. I need you to go quicker. Look here. I need you to go quicker.
Yep, gonna need a much bigger lens.